Scatterplot example 3. A person conducts the following experiment. He intentionally changes the number of shoes on the floor of his closet to see what will happen to the amount of usable floor space. The data is here, and you always have to know that the x-axis data is on the left and the y-axis data is on the right. And remember, in algebra class, when you look at the x and y axes, y is vertical, x is horizontal. All right, let's plot this graph here. So x-axis is going to be shoes. And first thing to do is put down the labels of the axes before you put down any points. And they're being measured in units of pairs of shoes. And I am going to be measuring the amount of floor space, or somebody measured the amount of floor space. And oh, that's not very good. There, now I've corrected it. I have floor space in squares on the y-axis and shoes in pairs on the x-axis. Both axes must start from 0, so I will put 0 in there. And now for the x-axis, the shoes, I see that I have to get up to 10 shoes there. This is a 20 by 20 grid, so I will make every 2 boxes equal to 1 pair of shoes. So there's my third, fourth, fifth pair of shoes, 6, 7, 8, 9, 10. So I'm using all of that space there. And for floor space, I see the maximum is actually 8. It starts out early and then it decreases, but 8 is the largest number there. So I could go by ones, but I'm going to go by 2 boxes equal 1, and I think I'll be able to fit those in. That's 2, 3, 4, 5 squares of floor space, 6, 7, 8, 9, and 10. Plotting the points, 2 pairs of shoes is at 8, 3 pairs of shoes is 7.5, which is going to be right there. And now I'll finish this up. Alright, I finished plotting all the data points. It looked like a line, so I drew a line of best fit, and that's what we're looking at now. It's a linear graph. The y-intercept is a feature of interest, and I want to determine what that is here, so I will do that, and that's just by looking at the graph and seeing the line would intersect the y-axis at that point, and that is at 9. Y-intercept equals 9 something, 9 squares. So what does that mean? Well, that means when there are 0 shoes, there are 9 squares of free floor space. The other important feature, and perhaps most important feature, of a straight line graph is its slope. And you can pick any 2 points to calculate the slope. I'll just pick these 2 points. I'll do a slope triangle here, which will allow me to put a number on the steepness of this line, which is its slope. And let's see, this point here is at 2 pairs of shoes. It's at 8 squares, and it goes down to, at this point here, it's down to 6. So that is a decrease, minus 2 squares. I'll just do SQ for that. Is that change, or what we call the, in our triangle, that's the rise. It's actually a drop in this case of 2 squares, and that happened over how many pairs of shoes? Well, this is 2 and this is 6, so that's 4 pairs of shoes. In our slope triangle, we call that the run. Many students have heard of rise over run is a quick way to remember how to do the slope calculation. So the slope, not the slopes, but the slope is equal to the ratio of the rise over the run. In this case, the rise was actually a drop, so it was minus 2 squares. I'm just going to put SQ for squares. And that change took place as 4 pairs of shoes were put down. I don't want to leave the slope in this form. I want to simplify. So if I divide through till I get 1 in the denominator, 4 into 4 once, 4 into minus 2 is minus 0.5. So the slope is best stated as minus 0.5 squares of floor space for every 1 pair of shoes. So that means for every 1 pair of shoes increase on the floor of the closet, there is a decrease of 0.5 squares of free floor space. Looking at my graph, I want to make sure I have everything. I have calculated the slope. I've determined the y-intercept. My axes are labeled and they have units. I do notice I don't have a title. Title is always what's on the y-axis versus what's on the x-axis. So in this case, it's floor space versus shoes. And there is a complete graph with the key features determined, the y-intercept and the slope. Hope yours looks the same.